Okay. And also, I realized that on my OBS, I forgot to turn on my mic, and that is not good. But don't worry. I think the Zoom's cloud recording will will work well because I enabled my mic there. Okay. Back to the actual OBS recording. Oh, actually, I'm also gonna like tune down my mic a little. There you go. Okay, let me make sure that like the screen is showing up. There you go. That's good. So, um, for concurrency, we deal with like how we can run certain things in parallel and whether that will like cause any issues. Okay, so here we pretty much address like a performance, response time, and availability. Well, latency and availability. Okay. Um, Maybe in one step we can run different things in parallel. Maybe in some they have to meet up and we have to synchronize certain things. Because certain parts of the system may require themselves to only run on one thread at a time. Yes, that happens. And we can achieve concurrency with physical and logical concurrency. Physical meaning using hardware such as multiprocessors and networks. Logical concurrency uses like different software packages. For example, we have the POSIX API, which we have learned in COE 628. Excuse me. Uh, and that's concurrency. You all can like read more into this after the tutorial as well. Hardware and software mapping. Basically, now that we have a nice hypothetical system in our heads, we're going to see how what type of hardware we're going to need and what components they're going to host. Components meaning different services and other subsystems that are available in software. Okay, here's an example on the right. You might have a client web browser that is your own computer, and then this will make HTTP requests to the web server. Um, and the web server will host like all these like registration, recommendation, and so on and so forth. And it will also query the database to store and manipulate data. So so you may also have to think about the specs of your servers or like whatever hardware you're gonna use. Do you need a really powerful one, or do you just need a nice average one to serve like to serve enough people as fast as it can? Okay, as fast as it can. Yeah. Okay. Persistence data management deals with like data storage. There are different types that we are shown. There's the file system, which is storing stuff in files. That is what our file explorer uses. The database, which well we have learned this in a CPS 510. Um, it's a computer that specializes in like storage of data. Uh, they use heaps and they do allow concurrent readers and writers. So you might have to address like some potential concurrency issues and so on and so forth. Global resources handling. That one is actually on the sample one of the sample midterm questions. And this deals with like what each component has access to. So we have to make sure that like the components don't step out of bounds and like do stuff they're not supposed to do. So that is why we have to organize like what each thing can do, basically. Here's an example access matrix for here's a sample access matrix. You may have some domains. I don't know, maybe some kind of like subsystems, and then you may have some um, more like services for the domains. By the way, you may have some kind of like objects that you want to work with, but you have to make sure that like only certain domains have access to certain files in different ways, like reading and writing, the most basic ones, and so on and so forth. Reading and writing, maybe executing the function itself inside the object. You may also have something like external hardware, like a laser printer, where like some kind of domain may have access to it to maybe print out a document. Who knows? So yeah, each entry in the matrix is called an access right, and it will list out like the things it has access to. Like maybe when you're making your access matrix, you're gonna write out like the service and the operations it's allowed to run. Okay. Next is software control. We take a look at pretty much like how the system's procedures will flow. Um, Here on the right side is just a an example of event-driven control. But there are two types. We have procedure-driven and event-driven. So in procedure-driven, the control is the control is inside the program's code, and that means that the user won't be able to like do anything about that because that is up to the developers. Event-driven control is when you use dispatchers and callbacks. This is where the user has good flexible control on like when they want their stuff done. Okay. You've seen the dispatcher pattern in like what is it? COE 538. Where we were doing microprocesses for a certain project, and we did it through the dispatcher pattern to organize our code. The next here is boundary conditions. This is where we look at how the system starts, terminates resources, and we also consider different points of failure. We use a use case diagram to organize this stuff, and we have to think about like the system's initialization. So what do we need to start up properly? Maybe we have to start registering some services. We have to also consider like what the UI is gonna should show us during startup as well. Termination is how the system cleans different things up. Maybe there are some like obsolete resources that we have to clean up during its runtime. So how do we do it? Like how do we detect this stuff? A lot of the technologies we use today like clean these things up by themselves, but it's good to take a look into it. And finally, we have to look at some possible points of failure, like what will like how something will go wrong, and how are we going to deal with it. Good system design should be able to foresee certain fatal failures, and it should be able to recover from them, or maybe like mitigate them by showing the user like what happened. Okay. So before I move on to middleware, does anyone have any questions? Feel free to speak up now. Nobody? Okay. Um, okay. So I'm going to treat this silence as nobody. Okay. So yeah, I'm gonna move on. Here we go. So next we are gonna address middleware. Middleware basically provides some like shared services and like shared like some shared like functions or whatever procedures across all different like components. Excuse me. So take a look at the diagram on the right. So without middleware, you're gonna have to connect to like every single like resource, like or every single component, and this looks like a peer-to-peer network, don't you think? Um, well, it's pretty messy, as you can tell here, like because like maybe like all the across all of the systems that the resources across all of the things that the left side A, B, C, D, and E need. Maybe there are some common things. And and that means we may have some like duplicate things in each of these computers or components on the right, which are labeled 1 to 5. So middleware like helps us deal with this mess by putting itself into the middle. Well, that is why it's called middleware. Um, and the left side can interface with the middleware to state what they want, and the middleware will deal with like dispatching this message to the right resources. So you can think of the middleware as a communication channel between independent systems. Okay. Um. Yeah. Moving on. So during the lectures, we are given like transport layer, application servers, message brokers, and business process orchestrators as different categories of middleware. Let's take a look at some of them. So in the transport layer, we have something called the message-oriented middleware, otherwise known as the MOM. Um, and and we have a MOM server that will send messages into a queue so that the receivers, whatever is receiving these things, will be able to pick them up and take them away from the queue. So I really would like to show you like an example called the simple queue service, which is actually a type of MOM server available to you on AWS. You feel free to look it up actually. Let me see if I can find a way to look this up. Hang on a moment. Let me take out a window. I'm going to like share the window. Okay. Everyone can see this, right? Okay. I'm just gonna. Oh, great. Okay. So we got some issues. Give me a moment. Uh-oh.
Recording in progress.
Okay, I have no idea what just happened, everybody, but apparently Zoom just decided to crash on us. Let's go. But that's okay. I'm back. I'll be okay. So let me just put this out. So I'm going to just show you all the AWS SQS. Um, OBS will not be able to see this, but it's pretty quick. You can actually access the Amazon SQS, and it actually acts as a really nice MOM server. I think take a look. Let's take a look at the features. You can actually take a look at this FIFO and stuff. And yeah, feel free to take a look at this. Um, they do have some really nice features over there. Okay, back to the presentation. So that is the transport layer. The next thing is what we are pretty much dealing with. That is the application servers. We've mainly focused on this one. Because it has the business logic. Because it has like the business logic that we're gonna implement. And they're gonna be used by client applications. It's also like it also provides like the communications, the security, the different like request transactions and data storage, or like it's also called persistence, and all these will be provided in the application servers. So it has quite a lot to do. You can split these into tiers. You can have the client, the web, the business, and the enterprise information system, which is the database. Here we're gonna use Apache Tomcat to uh, to work with this application server middleware. Okay. Okay. Um, Next up is the message broker. This is where we have the message like relay. Actually, we have a thing called the message broker in the middle, where like maybe some apps want to send a message to some consumer. So the message broker is going to relay this message and send it over to the right consumers. We have different message brokers here. We have the IBM WebSphere, and we also have RabbitMQ. Oh, by the way, if you're gonna use the message broker, do note that like they can be blamed as a for breaking the entire app if they actually fail. So do be careful. Maybe make a few replicas as backup, and I think you'll be good to go. But yeah, message brokers are indeed a potential single point of failure. So be aware of this. Maybe again, like make a few replicas. Um, okay. And finally, we have the business process orchestrators. This is where we, this is like where like people can like create logic for sending messages. For example, we may have we may want to create a file. When we create a file, we may want to take a look at the CSV file and then parse it as a JSON, and then and like do stuff to it to send it over to different maybe file servers and so on and so forth. Um, so these allow like people to connect multiple software components and manage their communications. Uh, and some examples we have here are Microsoft BizTalk, and we actually it's actually dead now, which is sad. But we have Azure, but we also have Azure App Service Hybrid Connections, which replaces BizTalk. So feel free to take a look at that too. Okay. The next thing we have is software quality attributes. We have six aspects in a typical scenario whenever we think about these attributes. We have the source, the stimulus, the artifact, environment, response, and response measure. Okay. Here's some of the simpler definitions that I typed up. The source is the one that stimulates the system. So it's the one that wants to do something. So maybe a user, a developer, some external system. Like it's kind of an actor of some sort. A stimulus is like the thing that's gonna happen. So it's the trigger. The artifact is the system that's going to receive this stimulus, and the environment details the condition it's in. The response is how the system will pretty much respond. Like that's what a response is, and this pretty much indicates the way the artifact is going to handle the stimulus. And finally, we're gonna measure this response using a response measure. It could be some kind of metric like time and the resources used to handle the stimulus. Okay, so some quality attributes that we're gonna consider include performance. This is where like we take a look at like how well the system handles different situations. How well does the system handle transactions? And does it have some latency? Hmm. We have to whenever you think about the quality attributes, make sure you also think about how we handle them. Okay, how we can handle different bottlenecks and so on. Maybe we need to replicate a few instances, like message brokers or any points that may become a bottleneck. So scalability is a special case of performance. It measures how well the system adapts to increasing input size. So how well does the system grow as more users use our app? Okay, so maybe you have a sudden group of 1 million users signing up for accounts. Well, maybe like we have some kind of like a load balancer that creates a new instance to handle the new load. That's fine. We might have a little bit of latency, but the system's doing the best it can. Who knows? Who knows? Maybe we're gonna need to upgrade a few instances, do some minor updates too. Modifiability measures how easy it is to make changes to the system or extend it. So this the people who stimulate in this scenario would most likely be the developers or system administrators. Maybe so pretty much the ones that maintain the app. Um, for example, you may want to add a new feature, and you're gonna measure like how much time it takes and how much stuff requires to or how much stuff is required to change. Um, it's a good idea to refactor your modules when you add more to them or when you change them, so that you can keep things nice and tidy and organized. Security, basically how difficult it is for the bad people to do like really unauthorized stuff and break the system. So how is the is it to break the system? Um, so in that case, the scenario would involve some either bad actors or maybe some idiots. So in that case, normally the system would like deny access to these operations and maybe return the not authorized HTTP code. Let me make sure that people let me make sure that like no one's in the waiting room. Not sure what's happening there. Okay. So, whenever you consider security, think about like a potential attacks that you're gonna witness, that's like your components are gonna witness. Availability is how pretty much ready the system is, or pretty much how how long is it up and running, like in like percentage in a percentage, like 99% uptime or something. Um, so whenever you want to update your system, you have to be careful with the availability aspect of the system, because if somehow your only instance is updating, it won't be able to serve any customers, and people are gonna complain to you, saying asking why is the system so slow today. So maybe like if the system needs to update to a newer version of their environment, like we can do it one by one and like reroute the traffic as needed. And like if you do it right, you should experience no downtime, even though maybe you might experience a little bit of latency in the other aspects. And finally, we have usability, which is how easy it is to use the system. So maybe a new user wants to learn how to use this new platform in their workflow. In that case, we should maybe give them a tutorial or something, and we can measure how much time it takes or how much effort it takes for the user to adapt to the new system and be comfy with it. Okay, so any questions so far on the quality attributes part? No? Okay. Um, so we have a components diagram. We have component diagrams. This is just a really brief like explanation of it. So a component diagram, um, it shows the relationships between like different parts of the software, like different services, different like components and stuff. And I'm going to also introduce like the parts of it. So we have components, basically like the pieces of the system. Maybe they want to interact with each other. So perhaps like one component will provide an interface, which pretty much which specifies like how like the components in the system can interact with it. And if the components needs to use this interface, we mark it with a socket. on the other side of the interface circle. Okay. Um, so here is the component diagram. That's 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 about it. So we're gonna on the exam, you're going well on the midterm exam, you're going to most likely draw some kind of component diagram. Uh, and here's what's inside a component. You may have like a collection of different classes that that works with. Oh, what does the symbol? Oh, what does the symbol between the components mean? As I said before, the circle is the interface. An interface pretty much specifies like how a components can be interacted. For example, if like the database or if the data access layer wants to allow like the business layer to create, read, update, and delete like a certain resource, we can make an interface calling it maybe like calling it maybe a to do crud, where to do crud is crud, and like that interface specifies like the operations you can do with like it the operations that's the other components can run. For example, I want to create a new to-do item. Okay, let's call the to-do crud, and we're gonna tell it to create a new task. Okay. Yeah. So Vishnu, very good question. Thank you very much for letting me know that you would like to know this.
Sorry, one more
Yeah.
thing on the last slide.
Yeah.
I don't want to keep everybody waiting, so I'll just ask this quickly. So
Go on.
like, so the component on the left side has its own interface, and the component on the right side has its own interface. Because
Um.
there's two arrows pointing. I don't know if that's like,
Okay.
I don't know.
Okay.
It's just sorry.
Yeah, it's okay. It's okay. It's okay. I understand. So the left side actually we is actually requiring the interface. There's only one interface.
Okay.
Yeah.
Okay.
So you see the socket on the left?
Yeah.
So the socket shaped symbol means that the component on the left wants to use this interface.
Okay.
And the component on the right is the one that provides it.
Okay.
Yeah.
Cool.
So yeah, it's good to know like what stuff your components are using. Maybe there are some interfaces they don't need anymore. So in that case, you might have to clean up a few things on your components diagram. So feel free to
Mhm.
take a look at how you implement your app and maybe do some practice on it. Yeah. So yeah, any
Okay.
questions on it?
No, that's it. Thanks.
Yeah, no worries. Yeah, so yeah, Andre, as I said, so the one component is providing some kind of interface, maybe not really data, uh, like not really actual customer data, but like maybe a piece of it. And the other side, so one component, the one on the right, provides the available interactions. The component on the left is the one that is gonna run these operations permitted by the interface. Okay, it's like a contract. So the right side is the one that gives you the contract, and the left side is the one that signs it and do stuff according to it. No worries, Andre. Okay, I'm gonna move on now. Um, if you all need to interrupt me, do speak up, please, and send me a message in in the chat if you cannot. Okay. Yeah, I'll be happy to help you all. So, inside a component, you may have a collection of classes working together to provide the interfaces that the component wants to provide. Okay, so here's a nice little component diagram I made. When I had my free time, we have a persistence. For example, that is the data access layer. That has a collection of classes like all these CRUD classes work together to provide a nice little cart use case, the where you manage your cart, add things to it, removes things from it. And these classes uh, work together to implement the operations the card CRUD would like to provide. Yeah. In the future, when you make your app in your labs, you might also need to consider like what each interface can offer. Okay, maybe one interface can only offer one operation, and maybe another will offer like four, three. Do consider the purpose of each interface whenever you design your system. Questions, anybody?
So in like the lectures, I see the persistence component and the GUI component. So what does the
Yep.
persistence one do? And like what part
Persistence
is
is
included?
the data access. So it houses the classes or services that connects to the database and queries from it, and they will also manipulate data with it. So persistence is like it's like the layer that manipulates actual customer data.
Okay, so that would that so like these classes here, are these like just Java classes in that case?
Yeah,
Or like
yeah,
subjects?
we're actually making Java classes in this course. Yes, but it doesn't have to be Java classes. Let me tell you, it can also be C sharp, JavaScript. Like it could be any
Okay.
language. This is a UML. This is a UML specification.
Yeah, I'm just asking that in
Yeah.
context to like the labs, that's all.
That's okay. That's okay. Yeah, good question. Good question. Yes, these are Java classes. And yes, and in this course, yeah, we do work with Java. So how you handling your app on your part, I guess. Like, is it? I guess like if you're able to handle like Java pretty well, I'm sure you'll be able to realize all these things in no time. Yeah. So keep practicing. Yeah. So Vishnu, any other questions?
No, that's really it.
Yeah. Okay. Thank you. All right. So yeah, so we reached the end of like learning about components diagrams, and it's already 12. Um, so I'm going to move on to deployments diagrams, which is kind of like components diagrams, but this time we're dealing with actual hardware. So so how do we deploy this app? Well, that's what the deployments diagram is. So how do we release the app to the internet, basically? Okay. So we have, for example, here's an example of like a way to create create a n tier an app using the n tier architecture because we have the business GUI and persistence. I didn't connect the interfaces there because I really have no space and it's not really the focus of the diagram. So I just scattered them like this. But yes, they are connected together in an n tier architecture. Okay, and we aside from the actual hardware we need, we also take a look at the relationships between them, like how do these devices or these objects interact with each other. So the example on the right, we have like an Apache Tomcat server, for example, hosting the n-tier architecture app, and this server will interact with the MySQL server using the Java database connection library, the JDBC. And the JDBC will be responsible for sending queries to the MySQL server in order to manipulate data. Okay? And if you look at the bottom, we also have us, the people with a browser, um, like sending an HTTP request to maybe the VM instance housing the Apache Tomcat server, and behind the scenes, the VM is routing our request to the server itself. And an artifact is like a product coming from some kind of software. It could be our browser, it could be source files, binaries, and so on. In our case, an artifact we have on our system is the browser. Okay. Any like questions on deployments diagrams? This is gonna be on the midterm too, so I would really like to help you all with any questions you have here. Going once, going twice, going thrice, and we're gonna move on now. Okay, so yeah, so whenever you deal with deployments diagrams, oh, VM is a virtual machine. Yeah, the green box, yes. Yeah, it's called a virtual machine. You like if you have worked with VMware, or if you have heard of DigitalOcean, you can make virtual machines that host your apps like backend and frontend. So a VM basically is like a machine in the cloud that hosts that allows you to install stuff on it. Yeah, that's one way you can deploy your app. You may also use dedicated servers too. Yeah, good question, Vishnu. Yes, I think I might as well like specify the full name of the stuff.
Hold up. Can you just specify? Oh, sorry. I'm sorry for asking this last minute. Just can you just specify like from the VM like what this connection with the HTTP request does with the browser devices with browser? Can you
Oh,
explain what that is?
you mean the little line? You mean the interaction between the browser and the VM?
Yeah. Yeah.
So the browser wants to maybe perform some request to the app. So we send an HTTP request to the domain where it routes to the VM instance, and the VM is gonna do its job and route our request to the Apache Tomcat server, which will then process our request and return us with a response.
Hmm.
Okay.
Okay. Okay. So it just they kind of send requests to each other to host the. I didn't catch that last bit. I don't know if I think I'm a little
Oh,
lost about.
it's okay.
Yeah. Sorry.
So the VM, like when if you get a little bit of experience with VMs, like you might familiarize with it a little more. But yeah, so the VM is hosted on some kind of domain, okay?
Okay.
And like uh our browser wants to be able to send our browser wants to send a HTTP request. So for example, maybe a request to create an account. Okay, we want to send this request to our app. So since like our send and because the VM is housing the Apache Tomcat server, um, the Apache Tomcat server is gonna actually catch our request that the VM is passing on, and it's going to do whatever it needs to provide a response to the new accounts, like creating a new account in the database, and like setting up stuff in the business layer and so on. So um, the server will then return a response, and the VM. I'm not really too sure about like what the VM does, so don't really quote me on this. But most likely the VM is gonna also pass the response back to the browser, and the browser is gonna process the response. Maybe displaying a welcome page or something.
Okay.
Yeah.
Got it.
So yeah, basically the VM is like handling the communications there too. If you have
Mhm.
if it installs some software that provides it, most likely it does because it might be part of the OS.
All right. All right. I
Yeah.
always thought like the browser interacts with the middleware, I think. Really, it's the Tomcat server that's kind of doing the communication. That's what I was thinking.
Yeah, the Tomcat server is doing the communications. Maybe it's opening up a port, maybe that allows the domain. Maybe the domain is aliasing the domain and port the server is catching. Okay.
Hmm.
Um, and the HTTP request like sending traveling through whatever aliasing domain is going to basically go to the particular go to the Tomcat server through that domain, through the actual IP address and the port that goes to the server.
Okay, and then this information is stored in the database, the MySQL server, like whatever, like this.
You mean the new account?
Yeah, that's what I meant.
Yeah,
Yeah,
the new account. So basically, maybe it's likely that your persistence layer is doing the CRUD, right? But it's inside the
yeah.
Tomcat server. The
Okay,
Tomcat server is gonna do JD is gonna open up a connection to the MySQL server through JDBC, and the persistence will query the database to make the new accounts for you.
okay,
Yeah. Yeah, I don't yeah, so that's about it. Like the deployment diagram is just showing like how the hardware is gonna interact with each other. It's a little bit similar to component diagram, I agree. Yeah. So yeah, Vishnu, any other questions before we go?
that's it. Thanks.
Yeah,
All
no
good.
worries. If you have any more questions, feel free to DM me because it's like we're kind of like we're kind of like we have under an hour left, so I want to get through as much of this as possible. Um, so finally, I'm gonna do a little review on sequence diagrams. So a sequence diagram allows like well, not allows, the sequence diagram shows like how the messages it shows where the messages go and pretty much when. Basically the order of the messages traveling. For example, here I have a really I'm not sure if you can call it simple, but here I have a simple execution of maybe some main function that is going to that that is that is going to create some nodes on a graph, and we're going to connect them with an edge by making a new graph. So maybe we are creating new resources. In that case, you mark the then in that case you label the create message as the create in angle brackets. And the arrow is gonna point to a new node instance, which will then have its own timeline. And I actually did it twice, in the order of n1 and n2. And then I'm gonna create a graph. And the And after I create a graph, I'm going to add an edge between n1 and n2. Uh, this will tell the graph to create a new edge object using n1 and n2 as your endpoints. And then I'm going to print out all the edges that are stored in the graph, which means and in our case, like in my implementation, I might tell the edge to give us the string form using the toString function. And the edge is going to give us back the edge string, which is the edge in string form, and then the graph is going to add it to some kind of edges list, and it will return that to us. Now, you don't really need to dig too much into it, but just know that each object or class, each object or service involved will have its own timeline, and the time goes from top to bottom. Okay, and if you need to like order your messages, you order from top to bottom. Okay, so maybe sometimes you're gonna call like another function in the class itself. In that case, you might have a little loop. You may have a little let me draw. You may have a little. Come on, really? You okay? Okay, you know what? That's okay. In that case, like you may have a little loop over here. Okay. You may have a little loop, and then you're just gonna write down like the function in the object itself. It's gonna call. So that's also one way you can like pass messages. You can pass messages to itself. That's actually okay. Okay. If you have any questions with sequence diagrams, feel free to DM me because I would like to get into the architectural patterns now. Yeah. So don't worry about like knowing no like interpreting this sample diagram. This is there to show you the different things you can do with it. Um, and that's about it. So we're gonna see this in action, like when we work with different architectures. Um, and yeah. So, any extra questions before we go into architecture styles? We have 45 minutes, so that's pretty good. Okay. Um, I'm gonna move on to the next part of the tutorial. We have the client server architecture. To begin with our architecture styles, this is a really simple two-tier architecture. So n is two in here. Um, and pretty much the clients directly query the server. Okay, like the server houses everything that the app can do, and the clients just connects to the server and queries from it. So some advantages you may so because the data is centralized, administration becomes easier. Maintenance is easy because you only need to maintain the server, upgrade it, and do whatever it needs. And it also reduces the amount of traffic you need to go through in order to reach your app's backend. Some disadvantages though, some data may be spoofed, and the server can will act as a single point of failure, meaning if it fails, the entire app fails and everyone will complain. Um, and if you're not careful, you may have some bad guy like installing a malicious script, and the clients will be compromised because the server might run them on the clients by accident, like might give the bad code to them by accident. Okay, so that's a two-tier architecture. Now, if we split them into n tiers, so more than two, um, we have the n tier architecture, which has the clients, which commonly we have the clients, presentation, business, persistence, and data layers. So we're splitting them into different layers. You can look at the right side. Um, the client is the guy or is the one that's like that is using the app. Like they want to see certain things on the screen. The presentation layer deals with like displaying whatever into whatever image, text, or stuff on their screen. Screen that's the user requests. Maybe like the sign up page, maybe the sign in, maybe like the main menu where like the website says hello to you. Um, like the presentation layer deals with that. The business logic layer houses our core operations of the application. So for example, like adding new like for example adding a new user would require the business logic layer to like verify whatever information the new user is sending, and then it's gonna also be the one to send a message to the data access layer, that or pretty much like the layer between the database and itself. Oh, whoops. uh, and pretty much like requested to manipulate some data. So the business houses the core operations. Okay. Next is the persistence layer, which is where you where the business layer will query for data and search for them. The persistence layer will have access to the database where it can manipulate the data in there. And notice that the presentation layer never interacts with the data access layer, nor does it interact with the database. So I know that's like this is a there's a let's build activity, but I'm not sure if we are gonna have the time to do this. So so maybe I'll save it for later, and maybe I might as well like maybe do one of these. Um, I perhaps have shown you the deployments diagram for an n-tier architecture and stuff. If y'all would like some practice on it, look at the sample midterm and the lecture and like week 6, which addresses the sample midterm, and and it does give you a nice detailed diagram on like the examples. So each architecture has its own like pros and cons. So in the midterm you're gonna have to address different aspects like performance, scalability, and some other like software quality attributes. So make sure you know your software quality attributes, and you should be able to do okay. You should do okay in here. So in the interior architecture, you have to send a message across like multiple tiers, which may take a whole lot of traffic to get there, to finish its operations. So that might be a quite a that might not be suitable for like really high performance applications. So consider maybe other architectures for apps that need really high performance. Scalability. You can replicate the instances in each layer in order to handle like influxes in requests. So that is pretty good. Although if you need more instances, you might need to pay a bit more money, and the system will get complex from there. Like complex as in like you might have to work with more instances, you might have to debug multiple of them and see if it's a weird hardware issue or not. So that might be something you need to consider in this architecture. Modifiability. The good thing about the n-tier architecture is that like you can modify each tier without affecting the other. Maybe a little bit, but like it's pretty minimal. Minimal changes are needed. So maybe you want to change up how the business logic layer works. Then in that case, you can like change that first, test it out, and then if it affects the data access just a little, you can make that little change in there as well. So little to no changes are needed in other components if like one layer decides to change. Finally, availability. Like if you have clones of multiple if you have clones of like multiple instances in each layer, you should do okay with uptime and availability as a whole. So if you need to upgrade your instances, like just maybe update one instance at a time. Don't update all of them at the same time. That's not really good practice. Like maybe like if you are hosting on some platform, just have the platform like do it one by one for you. Yeah. I've seen AWS doing it before, so that's how I imagine it. Okay. Any questions on the interior architecture? Once, twice, thrice, and we're moving on. By the way, because of time constraints, if y'all need help with something, just let me know. And like let me know through the DMs. I am in the third year engineering Discord. That's like maybe y'all are coming from. So yeah, that's about it. Otherwise, if y'all need my like Discord, you feel free to like I will like post it in the chat at the end. So make sure you don't go yet. Okay, the next one is the broker architecture. I'm sure you all remember the message broker, the good old message broker that like dispatches messages depending on like what's requested. So basically, this middleman can also is also part of the architecture called the broker architecture. So the broker architecture isolates the presentation and business layers by adding like a components to inter so that's like both layers can interact um and at the same time decouple from each other. So If you don't want if you want your GUI to only mind its own business and your business layer to also mind its own business, you can just add a broker that handles the routing from one side to the other, and the broker will also route the response back to the source, like back to the one that requested something. So so if you want to like add the broker component between the business and presentation layers, by all means go ahead. You might just need a class that maybe a component that's like a portal or somewhat, and then that portal will handle the communications from there. Yeah. So if you all want to like do like practice like this is like what I would like you all to practice with. Maybe I'll do one of the practice exercises if we have time. As I said. So the broker architecture, I'm not gonna go through all of the aspects, but all of the attributes, but like performance, the brokers can be a bottleneck. So maybe replicate multiple instances of a broker so that like they can cluster up, work together, and provide less of a bottleneck. But still, the broker is a bottleneck, so you have to consider that in your architecture. Scalability, like as I said, just make multiple broker instances and cluster them together, like just group them together basically, and then they will work together to route the requests as like you have a uptick in request rates. You can actually the good thing about the broker architecture is that because now the presentation layer and the business layer are decoupled or loosely coupled, you can change either one of them and like you have like minimal ripples to the business architecture to the business layer as well. As for security, well, because the broker because the broker is the one handling all the communications, it can be hacked and it can be sniffed. So make sure you add additional security measures to your brokers so that they can be protected from like people that sniff these things. Okay? Yeah. Oh, and of course, DDoS can really overwhelm the brokers, so be careful with that. Any questions on the broker architecture? Once, twice, thrice, and I'm moving on. I mean, yeah, I'm counting pretty fast there, so that was rather unfair of me. I apologize. Okay, moving on. We have the most popular architecture in the industry called the model view controller, and there are variants of them as well. But this is the base, the base architecture of MVC, model view controller. So we're pretty much this time we're going to split the app, split the entire like application into three parts. Model. The model is the one that manipulates the data, and it will also work with the how to say it can also work with the database in order to fetch data, manipulate data, and so on and so forth. Hold on a moment. I'm just gonna snooze this. There you go. Okay. Um. So the model can update the view. So the view is the one that displays the UI. And you can have multiple views of the same data structure. So for example, a really classic example is if you go to Google Docs and you look at your list of files, you can have them in grid formats, you can have them in a list format, uh, or you can have them in like list with little icons format and so on and so forth. So you can have different layouts of a UI showing the same set of data. So it's really nice so it's powerful in this regard. The controller allows user working with the view to send a request and like to manipulate some kind of data like fetching and updating. The controller can then pass on the message to manipulate to change the data to the model in the model. So so in a nutshell, the view sends input to the controller for processing. So you send a request. The controller manipulates the model data, and the model updates the view to show that's like your items are up to date. Now sometimes the controller may as well like updates the view directly as well. Like for example, I cannot find your item, so it will like bounce back to the view and tell it I cannot find this item, show the error message. Something like that. Okay. Um I would really like to do MVC architecture, but I'm gonna skip that for a while. We have half an hour. I'm gonna save this to the end. So this is these like in the lectures the lecture did is really provide like a nice description of the quality attributes. So I just gotta put them up from the top of my head and a little bit of googling for research. Um, so performance. One thing you need to be careful with is that if you want the model to update the view, it is costly because you're manipulating the contents of the website, which might also like take up a little bit of memory and time. So do be careful if you need to do like frequent updates. Maybe add a cooldown to it, so that the model won't have to be so that like the updates between the model and view wouldn't have to be overwhelmed. Scalability, you're gonna have to like replicate like the entire server because these three are kind of coupled together. Aside from the view though, the view is decoupled, so you can actually change um so that like UI you can like for the UI part, which is the view, you can change it up without having to worry about the model and controller unless you change the request structure of the controller. Um, but for scalability, it doesn't do very well because you have to replicate the entire server hosting all three architectures, hosting all three layers. I mean, and that's can be costly and time consuming too. Modifiability, as I said, the view, you can change up the view as many however you like, and it's not gonna affect the model and controller too much. But because the model and controller are coupled, one change to the controller, you're gonna also have to consider how you want the model to change its manipulations as well. Availability, how do I say? If your view is not available, then your app kind of falls apart because you won't be able to see anything. In that case, you may as well show a web page showing telling people that we are under maintenance or something. Model and controller, if either one fails, like your app won't function properly. So be careful with that. Maybe if like one server is having problems, like routes your traffic to another one that is fully available. But yeah, availability you have to think carefully, and consider how tightly coupled the three layers are. Okay, any questions on the model view controller? It's 12:32, so let's see what we can do from here. So hopefully we can address one of the questions, and I will show you. Uh, yeah. Okay. Nothing. No, like no one has any questions. It's okay. I'm okay with answering questions during the tutorial. Okay, I'm gonna move on to pipe and filter. Um, so the pipe and filter is where you have like multiple filters that basically multiple processes that are independent from one another. Um, and you start by sending some input into the pipe, and sending some inputs, this inputs, like for example, like maybe you have like a list of employees and their work hours, like the number of hours they have worked. In that case, you send it over to the input, to the input side on the left, and then uh, you're going to move this. You're gonna move the data along through the pipe, um, and then the pipe will take the input data into the filter, into the first filter, so the first step in the entire process. Once the thing is processed, once the first filter finishes its process, it's going to send over the results through another pipe to the next, and we're gonna rinse and repeat until we finish all of the processes or steps, and the last pipe will pump out the output for the user to for the browser, or for whatever thing, for whatever needs to receive this output to do stuff with it. So basically, this is really useful if you want, if your operation requires multiple processes that you don't know how long they're gonna take, but not too long. Okay, not too long. So it's good for like processes that go one after the other. So like one mini case that actually it kind of makes sense in this architecture is like processing paychecks. This really makes me reminisce my first year internship, because that is literally what I'm working with, what I worked with. Um, so you put in for example, you put in a CSV file, and you put in some hours per employee, uh, and then the first filter will calculate the gross pay, and then it will send over the gross pay data through a pipe to the next filter, which will calculate deductibles, for example, taxes and employee premiums. And then after the deductions, it's gonna send over through another pipe to post tax contributions. You can look up what those are, because I forgot. And then after calculating the contributions, we're going to send out the final like paycheck to for processing. That would be kind of like the output. So yeah, you can see that like each filter is processed one after the other, and the only thing that connects them together in a chain is the pipe. Okay, there can only be one pipe. I mean, well, there can be like one type of pipe between the two. You can have maybe multiple. Maybe like you can reroute the pipe to another filter instance if like the one you're going to is not available. So, um, performance. The more filters we add, like the more likely they're gonna receive some conflicting stuff. So, like be really careful. Like this particular architecture really isn't made for like time consuming processes. So if you have some app that requires this, like just make sure you at least like maybe give the user some control over it, or if you want to do everything automatically, update the user on it, I guess. Like these days are not really made to last too long. Maybe I don't know, like 5 minutes or so. That's fine, I guess. But like it depends on what filters you have, and like how the pipes are going, and where the pipes are going. You can add as many filters and pipes as you can to cater to like upticks in requests. So scalability is actually really good in this architecture. Modifiability, you can change since the filters are loosely coupled. You can change up one filter without affecting the other. So that's a really good thing. Um, and the pipette filter is made so that modifiability is not a concern. So that's a so yeah. If you have different parts where you want to modify, feel free to do it. Feel free to do it. One change in the filter, and the other filters will remain like mostly the same. And do remember that the filters are independent from one another, so don't like couple them. Okay. Availability, well, the good thing is that this architecture is also known to be fairly resilient because one failing filter and you can try to reroute your traffic to a healthy filter so that the healthy one will process your request from there and then it will go back on track. Of course, unless the filter has its own inherent errors, like because maybe the developer missed a semicolon or something, then in that case, like the entire filter will fail prematurely, and that is not going to be good. But assuming that assuming that the code it runs fine, uh, like if the filter is being overwhelmed, maybe make another instance of the same filter and reroute your traffic or split it. Okay. Peer to and The last architecture I want to address is the peer-to-peer architecture. I'm going to so in like basically in a nutshell, instead of having like one central server where the clients connect with one another, where the clients connect with, so basically um that server handles all of the app logic and stuff. Instead of that, you may have multiple servers or multiple clients that will connect with one another as peers, and they can handle transactions between them directly. Okay, so we don't connect to some central server anymore. We're connecting with we're connecting directly with we're connecting with multiple computers like directly. So you can see that this is an example of a peer-to-peer network. So maybe one computer goes to another. One computer may send a request to one of the peers it's connected to, and the other will respond back. So, so each peer in this architecture acts as both a client and a server. So the client may send a request, the server processes them, one of the peers will process them and gives you back the response. So this will decentralize your app so that like you don't have one single source of failure. Instead, you have like if like some of the uh, peer fails to do its job, then like you can ask other peers to do it for you. Okay. So here is one way you can deploy your peer. You can just connect one, for example, in a library where it has multiple branches. You can have like one branch in one server, one virtual machine, the other in another virtual machine, and so on. Um, and you can connect them through HTTP requests, kind of. Kind of. You can actually forward your request to other branches to query whether like a book is available for borrowing there, for example. Okay. You can also maybe have an electronic store with multiple branches in their own websites, and you can then send a message over to your other branches to see if those branches have the products you need in case the one you're choosing doesn't have it. Okay. I will leave this exercise to you for practice. So because of like how decentralized your the P2P architecture is, The performance in the performance aspect of things, each server, well, you don't have like one single point bottleneck anymore. You have peers that will like handle like that will like distribute the load for you. That will make things run more smoothly. Um, Updating data, however, because of how like everything is decentralized now, updating data might become a hassle. So maybe you might have a nice like a peer tracking application somewhere where it will like sense peers and like updates data when needed. But that's optional, I think. But I think sometimes like you might need it because you want to see like which like you might want to see all the peers are doing like and how they are all doing. So that's one way you can do it. Scalability, you can add as many peers or remove them depending on your like request rates. Like maybe just an uptick, then you just add a peer. If there is not as much traffic today, we can subtract a few peers and everything will still work fine. Security, um, if you're not careful with your network, some malicious actor can actually ruin the entire network by hacking one of the machines and spreading the virus to all the other ones. So be careful with those and try to like do extra work on it. Do extra work to protect each node and ensure that they comply with with what you're doing, what you're trying to do. So for availability, this is like a really good boon for peer-to-peer architecture. Availability, like is for availability, if one peer is not available, you can have other peers that will do the work for you. So so it's okay if the one you're querying doesn't work out, doesn't work, doesn't work properly, you can send it to another peer, and the other peer will give you will like try to do the job for you as well. So with that, we're done. We have about 15 minutes, so I'm not sure if I should like go over one of the exercises I have over here. So yeah, any questions you would like to address today? Like, will you post these slides? Oh, well, yes, I will. I will. I will post these slides because like y'all are gonna need it for like practice purposes. I'm not sure if we're gonna have the time to do it, but if you all want to, I may also like show you how to like create a component diagram on visual paradigm as well. But I don't think I'll be able to go through an exercise entirely. Okay, awesome. This was a great review. Yeah, thank you very much, Andre, for sticking by. For those who have no problems so far, thanks for the review. It was great. You're welcome. Uh, so for those who still need to ask me questions, feel free to stay behind. We have about 15 minutes. Yeah, you can also ask me something about how to make a component diagram or a deployments diagram as well. I can show you a few things as well. Yeah. So just give me a shout, send me a text message or something, and well, not text message, a chat message on Zoom. Not text message. I don't want people spamming my phone. Thank you. You're welcome. You're welcome, everybody. Yeah. Okay. For those who remain, does anyone have any questions? Oh, okay. People are leaving now. All right. Yeah, so Andre, feel free to speak up as well if you're able, or you can send me a text message or a chat message. Okay, I'm just going to yeah, I think I'm good now. We'll do some practice. Thank you. Okay, no worries, no worries, Andre. Thank you very much for coming today, and yeah, I'll see you all next time tomorrow. Bye. Let me stop recording.
Recording stopped.